Let's go. Question Niban. Okay, so oh sweet, a little particle motion guy, right? And we focused on these guys quite a bit as we were reviewing for this AB exam. But this is here we go. AB number 2. This is strictly an AB question. So once again, make sure you look it up so you have the question handy. I'm going to go to my screen here just so I can fit more in it, and these videos don't take too long. Okay, you guys. So here we go. Question A. All right, question A. So they introduce, it looks like they introduce a particle P, where they give us a velocity, and they also give us an initial condition. So we've got this velocity guy right here, which is sine of t to the 1.5 power. And they give us an initial condition that at time t equals 0, x is equal to 5. And then they introduce a q like right away. Sometimes they introduce q later, but how about that? We get to work with this guy right away. And that's just t minus 18, 1.25 to the t power. So hopefully when you were taking this test, right, you just plug this stuff in your calculator ASAP. Okay, Part A. Part A asks us to find the positions of P and Q at time. Oh, come on, AP. Man, all right, let's go. This isn't too crazy, right? Because for this one here, we're just going to find the position of particle P at 1, which would be equal to, right, P at 0 plus the displacement from 0 to 1 of velocity. That's it. That's all you got to do, right? And then would that be 5 plus 0 to 1? And so this is in sweetie sweets. This is a calculator question. So all you have to do is put that guy into your calculator. All right, x of q. Where's q at? 1, right? Still 1? Yep, still 1. So it'd be the initial condition of q plus, man, and this would be worth at least a couple of points, right, you guys? So hopefully you guys did awesome on this one. I don't think it could be any more straightforward, okay? But if you put those two into your calculators, I'm going to put this in right here, you guys, really quickly. Let me hit pause. Let me go. It's not going to take too long. Okay, for the first one, I got 5.371. Okay. And for, let's see, for the second one, just making sure I don't make any little mistakes, I got 8.564. Okay, so that's probably worth about a couple of points. That's all you had to do for part A. Sweet. All right, and like I said, I'm gonna try to go over these things a little quickly, okay, you guys? Look at this one. This one's pretty interesting, huh, you guys? This one here says, are particles P and Q moving toward each other or away from each other at time t equals 1? Explain your reasoning. Okay. So I know for one, I need to know at time equals 1, okay, if these guys, what their velocities are. Because their velocities will tell me if they're moving to the left or they're moving to the right. Okay, so let's go ahead and find their velocities first, right? That's just a math 8, right? Because we already put these in our calculators in y1 and y2. If I math 8 at 1, I get approximately 0.841. And for this one, I get actually a -1. Okay, so this dude's moving to the right, right? Because it's greater than 0. This guy's moving to the left. So you know what I would probably do is do a little like where are we? Where are these dudes? Okay, and P at time t equals 1, its position was at, maybe I'll write this below. That's P, it's at 5.371. This over here is Q, and he's at 8.564. Oh, sweet. And so P's going to the right because it's greater than 0. Q is moving to the left because its velocity is less than 0. So guess what? They're going towards each other. So I'm not going to write this out, but hopefully you write something out that helps the AP grader to understand what I was writing down. And what I would say is, hey, since P is at position 5.371 at time t equals 1, and its velocity is positive, it's moving to the right. Q at time t equals 1 is at a position of 8.64 at time t equals 1. And its velocity at time t equals 1 is negative, which means it's moving to the left, which thus means P and Q are moving towards each other. Okay, I'm going to erase some of this here. Maybe I'm going to need some of this later. We'll see. Let's see what letter C asks us for. Got it here on my other screen here. Okay, so let's see. Find the, oh, come on. This is sweet. It's just straight up, straights forwards, right? She's just asking me to find the acceleration and tell me if the speed of Q is increasing and decreasing, right? So the acceleration of Q at time equals 1 would be the derivative of velocity of Q at time t equals 1, which is just a math niners. And if I do all of that in my calculators, I get 1.027. And if you remember, the velocity at time t equals 1 was equal to negative 1. So that's greater than 0, that's less than 0. So what are we going to say? Well, once again, just a statement giving an explanation for what my work showed. And that is, if acceleration and velocity are different signs or opposite signs, then we know the speed of that particle Q is decreasing at time t equals 1. All right, here we go. I'm going to get more space because boy, has this been nice and easy, Japonesey, right? The last one's got to be tough. There's no way it can't be tough. What the what? Find the total distance. Let's go. Give me them toes. 9 out of niners, right? This is just total distance. I think the only way you miss this one is if you don't notice that it's particle P and it says particle P from 0 to pi. So that's just the integral from 0 to pi of total distance, absolute values, right? Absolute value. That's why I'm always positive, right? Which is V of P. That is it, you guys. All I got to do is math 9 that guy and make sure I remember that the absolute value button is in that math, dude. Right? If I do all of that, I get an answer of 1.931. That's a 9 out of niners. If I've ever seen a 9 out of niners, you know, I'm going to predict. I am going to predict that the toy problem is coming up next, right? Because right now, I don't know about you, didn't even actually use my calculator that much. I guess in problem 2 you did, not in problem 1. But you should probably be feeling pretty darn good about yourself. See you soon. Lots.